Have you ever wondered what the difference between our first integral, this our integral A, and our integral B? In my last video, I explained the difference between the integral A and the integral B. So I spent time to explain the difference on this particular integral. I get what I'm saying now. I explained this particular integral in the last video. So today we are going to be talking about this integral, which is called what? A closed loop integral. It is called what? A closed loop integral. And one thing you have to understand about this integral is you can also call it a what? A closed line integral. You can also call it a what? A closed line integral. And this simply means that what? It simply means that we have a curve. Are you seeing that now? Like we have a curve, like let's say a point is starting from here. All right, a point is starting from here and it goes like this. Are you seeing that now? Let's say it goes like this and stop at this particular point. This is what? This is a line integral. I get what I'm saying now. Now, when we talk about this closed integral, it now means that there is an additional information. I get what I'm saying now. It means there is an additional information that as it gets to this point, it now returns, like it returns back to this particular what? Point. Now you may be seeing this as something that is complicated, but it is not complicated at all. It means it have this starting point. This is the starting point, and this is still the what? The end point. So that is why it is a what? It is a closed loop integral. I get what I'm saying now. That is why we say it is what? It is a closed loop integral. So it is just like you are walking. Let's put it in form of you walking. You are walking from your house. So you are walking from your house. This is your house. You are walking from your house to a store. This is the store. Now the store is not your house, right? So since the store is not your house, you have to return back to your house. So your house is the starting point, and your house is also the what? The end point. Are you get what I'm saying now? So let's see example. Let's see example. So in this our example now, I'll be explaining how you are going to apply this when you have any questions like this in mathematics. So watch and learn. Don't forget to like this video and share this video. Don't forget, I already said that the idea of this is that you are returning. I get what I'm saying now. There is a point of return. All right. So now let's say we have an example like evaluate the closed integral. Evaluate the closed integral. Evaluate the closed integral. All right, so this is the closed integral we have here. We have 3 dx plus 5 dy. Are you seeing this now? So this is 3 dx and what? 5 dy. Now so we said along a closed path, you are going to be given the path. Don't forget, just like I explained in my diagram here, along a closed path from 0, 0 into 0, 0 again. Are you seeing that now? So this is the points. So you want to evaluate this. How do you evaluate this? Now the first thing you have to see is that you can see that this is not having a C here. So that is another example I'll be explaining in day 3. Don't forget, I'm explaining this, and this. Are you seeing that now? So we are currently on this particular explanation. So since there is no, you can see that there is no letter C in this place. I get what I'm saying now. There is no letter C there. So what does that mean? That means that it is not on that particular part. I get what I'm saying now. So To do this, the first thing, if you want to do it in a very simple way, first separate the integral, like open the integral. So I can say this is integral 3 dx, then plus integral, are you seeing that, integral what, 5 dy. Are you seeing that now? Then I can also rewrite it as what, as 3 closed integral what, dx plus 5 closed integral what, dy. Are you seeing this now? This is one thing that I can write it as. Now don't forget, from this my explanation that I explained before, you are starting from this point, you are starting from a point here, you go towards this part and you come back to this what, to this point 0. Are you seeing that now? You go back to the what, to the point 0. That means if you start, and if you look at the part we have, your part is starting from what, from 0 back into what, into 0. That means our integral dx here is the same thing as what, as 0. Do you understand that? That means your integral dx here, the closed integral dx here is 0. That means I can say 3 into bracket what, 0 plus, are you seeing that now? Plus our integral dy also is also starting from what, from point 0 up to what, again, to point 0. So that means our integral dy is also what, 0. So that means I can write this also as 5 into what, 0. And that means our answer will be 3 times 0, 0 plus 5 times 0, 0, which is what, 0. Do you understand that now? So this, what do you now see? Because how will you conclude this? The conclusion is also very important, as it will help you to understand what we are saying. So what do you see with this type of thing? I get what I'm saying, with this type of integral that because it is a closed loop, it means you would always return. Because it is a what, it is a closed loop, it means what, you will always return. So if you start like this, you will always return back to the coordinate, back to the point. So the net charge, the net change in a closed loop is what, is always 0. The closed loop is always what, is always 0. So if it is just like a line integral, if it is a line integral like this, I get what I'm saying, it is line integral like this one means like you are just working from your point A, you are working from your point A to, let's say, your point B. Are you seeing that now? You are working from your point A to your what, to your point B. But if it is a closed integral like this, it means you are working from your point A back to your what, to your point A. You are completing a what, a cycle. Do you understand the difference now? So that is why our net charge on what, and our dx will always be what, 0. On your what, on your dy will also be what now, 0. Do you understand that now? So that is what we have on this particular example. I hope you understand that very well. I hope you understand that very well. So this is the second day of explaining the difference between the integrals. All right, so thank you very much for watching, and I will see you in the day 3, where I'll be explaining the third integral, which is what, the one that now have the what, the letter C. I get what I'm saying. It has a particular part. You can see that the part here is what, is zeros, but in this our day 3 now, I'll be explaining where we can have from different parts. So I can have like from 0 to 1, from 0 0 to 1 0 to 1 0, and the likes. I get what I'm saying now. So watch out for the third day as I'll be explaining that. All right, don't forget to subscribe, like, follow, and share this video. Thank you very much, and I will see you in the next one. All right.